Hello, let's continue our Sudoku adventure with Insert Obligatory Lunch Pun Here by Calvinball. So this continues our sandwich sum theme week. Hope you're enjoying it. So this has sandwich sums and Nabner lines. Let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have sandwich sums outside the grid. Take this 10 for an example. What we need to do is we need to find where the 1 and the 6 are in the row. So maybe the 1 is here and the 6 is here. And then the digits between the 1 and the 6 sum to the value outside of that row or column. And so these three need to sum to 10. So we could do, for example, 2, 3, 5. And, the order doesn't matter. What matters is that between the 1 and the 6, the digits add to 2, 3, 5. Or sorry, the digits add to 10. And so between the 1 and 6 in this column, they add to 6, etc. We also have these yellow lines in the grid. These are Nabner lines. If a digit appears on the line, then that digit and the digits consecutive with it do not appear. So, for example, if I put a 2 on this line, then the 2 doesn't appear anywhere else in line, which actually in this specific puzzle, that doesn't matter because they're all in the same row anyway, or column. But also the 1 and 3 don't appear. So I can't put a 1 or a 3 anywhere on this line now that I have a 2 on it. So no two digits on the line can be consecutive, basically, or the same. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, 12 is a big number. If you think about it, the entire row adds to 21. 1 through 6 adds to 21. And the 1 and the 6 are defining the region that is the sum, so they are never part of the sum. So that's 7 that cannot be part of the sum. 21 minus 7 is 14. And so that means that the sum of the digits that are outside of the 1 and 6, that are not between them, is 2, which is the only way to sum to 2 is to just be a 2. So we've got a 1, 6, either like this or like this. And then the outside, the digit that's outside of them is a 2. So we could have a 1, 6 pair here with a 2 there. Or we could have a 1, 6 pair here with a 2 there. Now, these two we can't leave, but these are only from 1, 2, 6. That is true. Okay, now the 10 is going to have 4 outside of it. Now you'd think, oh, I can do 4 as a 1, 3, 1 plus 3. But remember, 1 is never part of the sum or the outie, right? It's the 7 that it was excluded from the 21. And so 10 is the same, except the outie is 4. So these are from 1, 4, 6. Okay. Now, the 6 is pretty small. What we can't do is a 1, 6 pair with just a 6 in between, because again, the 6 can never be part of the sum. So, and we also can't do a 1, 2, 3. Like if we wanted a 1 here and then a 6 here, in order to fulfill this sum, we'd have to do 1, 2, 3, and that would repeat the 1. So we are limited to being a 2-digit sum, and we can't do 1, 5 for the same reason, can't use the 1. So we're going to be somewhere, not necessarily here, we're going to be 1, 2, 4, 6. And the outies are going to be 3, 5. So I think this Nabner kind of is interesting for that reason, because we can't put both the 1 and the 2 on it. So it's either 1, if this were here, this would be the other 1 too. And it wouldn't be the 2 because we know the 2's outside, and it wouldn't be the 1 because we know the 1 can't go there. So actually that doesn't work. So let me talk about why this doesn't work. So first of all, if our sandwich were here, so this was a 3, 5 pair, right? If our sandwich were here, then the Nabner can't have both a 1 and a 2 on it because they're consecutive. So that would mean that this would have to be the 1, 2 that isn't on it. But here's the problem. This cell can't actually be 1 or 2. If it were a 1, that would define our 12 sandwich to have two outies, at least, which it doesn't. It has the 1 outie, so it's not a 1. And if it were a 2, the 2 would have to be inside of our 1, 6 pair, which is either here or here. And it's not. It's outside. And so it can't be any of those digits, which means that we don't have our sandwich here, which means it's either here or it's here, just to color that, which means this is an overlap. This is always 1, 2, 4, 6, because these two have to be part of our sandwich. Now, that means that either the 3-5 pair goes here or the 3-5 pair goes here. And then if this were our sandwich, this would have to be the 1-2. That doesn't go on the Nabner. I'm not sure if we can define any more than that. That maybe wasn't as helpful as I hoped. 3-5 pair here or 3-5 pair here. I wonder about the 9. So we obviously can't do 9 and 1. 9 and 2 is very possible, 3, 6, or 4, 5. 9 and 3 is just possible if we do 2, 3, 4. So, but that's it. So we're length 2 or 3 between the 1, 6. So 3-cell Nabners are interesting, and I don't know if this is going to, maybe this is helpful or maybe it's not. We'll see. But why are 3-cell Nabners interesting? Well, you can kind of think of them as being an entropic line, but more restricted than that. Because as soon as I put a 1 or a 2 on the Nabner, I can't put another 1 or a 2 on it, or they'd be consecutive. And then as soon as I put a 3 or a 4 on the Nabner, you can't put another 3 or 4. And so now I can't have a 1, 2, or a 3, 4, so I'm left with a 5, 6. And that's always going to happen. I need 1 from 1, 2, 1 from 3, 4, and 1 from 5, 6 in order to not have any consecutives. If I have 2 from 1, 2, or 2 from 3, 4, or 2 from 5, 6, those will be consecutive. So that's one property. But in addition to that, there's 2 special numbers. If I were to end up with a 2 anywhere on a Nabner, that forces the 3, 4 to be a 4, which forces the 5, 6 to be 6. To be 2, 4, 6. If I put a 5 anywhere on the Nabner, I have to do 5, 3, 1. So the question is, does this have a 2 or a 5 on it? We know it doesn't have a 2 on it, first of all. Oh, that's interesting. It does not have a 2 on it because we already said the 2 is here or here. Therefore, it must have a 1 on it. Because remember, it's entropic. We have to have 1 from 1 or 2. So if this has a 1 on it, then neither of these can be the 1. So the 6 is on the outside. And so that means that either this is our sandwich or this is our sandwich. But if this was our sandwich, we would not have a 1 on here. So this has to be the 1, and this has to be the 6, and this is our 2. With the 2 on here, we are left with 4, 5, or 6 only. This can't be a 6. Okay, so with the 1 on here, we now need a... Oh, and there's definitely a 5 on... Oh, okay. Sorry, it's a little bit simpler. We knew that... Oh, sorry. No, this could have been a 6. But now it's a 1. Naively before, this could have been the 6 with the 1 here. But now we know that this needed a 1. So it was forced here in order for the sandwich to work. So that's correct. But now it has a 5 on it because it doesn't have a 6 on it. And so with a 5 on it, just like I said, it makes it a 3-5 pair. And now this is our 4. Okay. Well, if this is 3-5, we know this is also 3-5 because we just talked about how the 3-5 pair was here or here. So this is from 1, 2, 4, 6. If you remember, this the other 1, 2 has to be off of this Nabner. So this is 1, 2 only. Okay. This is a 4, 6 pair. This is where they go in the box. And this is 1, 2, 3, 5. For what it's worth. Well, we know this isn't a 1 because if it was a 1, then our sandwich sum will be 0. Either this is a 1 or this is a 1. Oh, sorry, no. Either this is a 1 or this is a 1 because we need to have 2 in the middle or 3 in the middle. So the 1's in one of these two. That points up. Huh. Now, what else can I do here? I have this Nabner I haven't looked at much. Oh, sorry. We know where the sandwich is, so the 2, 4 is in the middle. Right. And then this can't be 6. So this has to be the 1 and this has to be the 6. Okay. For some reason, I just didn't consider the fact that the 1 and the 6 were around the 2, 4. Anyway, that places the 1 here. That makes this a 2, 4 pair. Sorry. No. This is 3, 6, or 2, 5. Sorry. This is 3, 6, or 4, 5. But 6 is gone. So it has to be 4, 5. Okay. I got very confused there for a second, but we're good now. Leaves a 2, 3 pair behind. This can't be 6 anymore. Can't be 1. Well, this isn't the 6, because the 1 ended up here. This is the 6. This is our 4. That's 2 and 4. Oh, I could have realized that wasn't 4 because 4 had to be outside of the 10. I forgot. That's 5 and 4. That's 5. We get the 6 and the 4. There's a few things I forgot that would have made this a little cleaner to solve, but that's okay. That's a 3. That's a 1. That's a 2 and a 3. That's 5 and 3 and 5. This is a 1-2 pair. We get 2 3s in the corner. This is a 2-3 pair. This is a 5. Up here we need 3 and 5. That goes like this. Down here we need 4 and 6. That goes like this. I'm guessing this number finishes something. Here we need 1, 2, and 6. So the 6 can only go here. This is 1 or 2. And what are these down to? 1, 2, 3. That's not a 1. So we know there's a 3 on this dabner, meaning there isn't a 2. And so this is 3, this is 1, this is 2. We get the 1 and the 2, the 3 and the 2, and we're done. All right, cool puzzle, Calvinball. This logic here on this nabner, that 3-cell nabners have to be entropic, was really important to think about because it forced it to have a 1 on it because it did not have a 2 on it. So that's something that could have been done right away, but I didn't really think about that. I thought there was other stuff I could look at. Anyway, so I think the really clean solve path does that first, which forces both a 1. It forces this to be the 1, 6. The 1 and the 6 exactly. Forces this to be a 3, 5 pair, forces that to be a 2 and that to be a 4. And that gives you a really nice seed at the start. Cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.